In this video presentation, we are going to look at the gas cyclone separator. We will look on its main design feature and how its working advantage and disadvantage and some of its common application in industry. First, we talk about the basic of cyclone separator. There are two main design of cyclone separator. One is gas cyclone and another is hydrocyclone. Gas cyclone are used to remove entrant or dust particle from the gas stream, and hydrocyclone are used for separating fluids of different densities. Gas cyclone separator are grouped two main categories, reverse flow and axial flow. Reverse flow cyclone separator gas enter at the top of the separator body and flow downward, then flow back upward and its discharge. For axial flow cyclone separator, gas enter at the one end and its discharge at the opposite end, like shown in the video. Now we talk about the component and its design. A reverse flow cyclone separator has no moving part and simple design. The main cylindrical part of the cyclone separator is known as the body and upper body. The gradually narrowing conical section is known as cone. Gas enter tangentially through the inlet at the side of the cyclone separator. Dust particles within the gas stream are separated through the gas stream and discharged through the reject port at the bottom of the cyclone. Clean gas exit through the accept port at the top of the separator. Now we talk about the working of cyclone separator. Gas containing dust particle enter at the high velocity through the tangent inlet at the top of the cyclone. The gas flow into the cyclone body at the tangent and begin to flow in a circular downward following spiral toward the lower reject port. This downward flowing spiral is referred to as a spiral vortex. The cyclone diameter gradually decreases, which causes the gas velocity to increase. The outer vortex creates an additional inner vortex closer to the center of the separator body. This inner vortex flow spiral upward toward the accept port. Particle with more inertia or heavy dust particle will impact with the side of the cyclone separator, while the particle with lower inertia will remain within the gas stream. The particle with low inertia will not continue to travel in a straight line. They will instead travel spirally along the gas stream. Particle with large inertia will be less affected by the vortex and will continue to travel in a straight line. This straight line trajectory causes the high inertia particle to move out of the gas stream and impact with the cyclone separator body. These particles then fall to the base of the cyclone separator and move out of the reject port. In this way, dust particle of certain size can be separated from the gas stream. Another way to think of this process is to think of higher density particle colliding with the cyclone separator body, while less denser particles are retained within the gas stream. Let's look at the important aspect of cyclone separator, efficiency of cyclone separator. The efficiency, also known as capture recovery rate, is a measurement of cyclone ability to separate particle from the flowing gas stream. Because particle is different size, the efficiency rate is usually given for varying particle. Factors affecting efficiency. There are several factors that can affect the cyclone separator efficiency, like particle size, particle density, volumetric flow rate, pressure drop, cone length, body length, ratio of accept port to reject port. Even the smoothness of the cyclone separator internal surface also affect the efficiency. Application of cyclone separator. Cyclone separator are utilized in many applications due to their low cost, simple design and high efficiency. Cyclone separator require no bags or filter and it require only low maintenance cost. Typical application would include a sawmill. Sawmill generate a lot of dust which must be extracted from the mill. The dust air then passes through a cyclone separator where most of the wood must be separated from the air stream. The clean air is then discharged directly to ambient air and the wood dust is recycled or disposed.
So this is a cyclone separator equipment, and here's the feedstock section in which the feed is put in. Here's the regulatory valve, and now it's the cyclone separator main upper cylindrical body followed by the lower conical section, which is gradually narrowing, and at the bottom there is the outlet or the reject port. And now let's demonstrate the working of a cyclone separator equipment by putting in the sample feed first in the feedstock section. And here's the air blower through which the air is blown. Now after putting the feed in the feedstock section, we will switch on the main power supply and the air blower respectively. Now the cyclone separator equipment is basically in action, and we will partially open the bypass valve and the flow control valve. So now after opening the regulatory valve, the cyclone separator is now separating the feed on the basis of its density, and the denser material is separated at the bottom of the separator in the outlet or the reject port, and the less denser or the clean air is separated out from the upper section of the cyclone separator in the clean air section.